Okay, so we're looking at polynomial terminology. Here's a polynomial, has 1, 2, 3, 4 terms. So this a value right there, that is the leading coefficient is what it's called. And I'm going to fill this in first. Leading coefficient. Now what that means is it's the first number that comes when this is written in standard form. It says right here that a standard form is written in, it should be decreasing order of exponents. So you can see this has a degree of 3, then 2. This is really 1, and this really is to the 0 power here. So this first term right there, the leading coefficient, and this is written in decreasing order, which puts it in standard form. Now, because this is of degree 3 right here, we call that the cubic term. There are 1, 2, 3, 4 terms again. So this is the cubic term. This we've studied in semester 1, a squared term. That's called the quadratic term. The first power, a linear term. And then finally, a constant. Now, the reason this is called a constant is because, for instance, let's say that we had, instead of this generic polynomial, we had f of x equals 2x to the 4th minus 3x plus 5. And then I said, well, let's make x equal to 6. And if I plugged in 6 here, I would get 6 to the 4th times 2. That would be the value of this term. This one would be negative 3 times 6, the value of this term. And this term would be 5. Now, if I said, let's make x equal to negative 3, then this term would be whatever value I got when I plug negative 3 in. This would be whatever I get when I plug negative 3 in. I guess that would be an easy one to do. Negative 3 times negative 3, 9. And this one would still be 5. It is constantly 5. That's why it's called a constant term. So, as we're classifying these, we can classify them by the number of terms that they have. This particular one had 4. If it only had one term, we would call it a monomial. If it had 2 terms, biplane, bicycle, binomial. If it had 3 terms, tricycle, triceratops, trinomial. 3 terms. And if it has more than 4 terms, we just call that a polynomial. Now, there are standard common forms of polynomials, and if you ever see one that has f of x equals ax plus b of that form, that is linear. We've studied that before, and we saw it like this, y equals mx plus b. Different letters, same form. We've definitely studied in semester 1 these quadratic. So it's based off the degree of the leading term there. This one, cubic. So here are some examples of polynomials. This one, 1, 2, 3, 4 terms. The leading coefficient, I'll abbreviate LC, is 3. The leading coefficient. Now the degree of the polynomial, that's the highest degree that's here, and it is written in standard form because we have 7, then a degree of dropping down to 4, then dropping down to 1, then dropping down to, this is really x to the 0 power. So the leading coefficient's 3, the degree is 7, the highest degree of the polynomial. This one does not have a quadratic term. There's no squared term, but it does have a linear term. So the linear term is 7x. It also has a constant term. The constant is negative 4. That's a constant term. All right, next example. Negative 5x. This only has one term, so it is a monomial. The leading coefficient, negative 5. And this term right here, it's just negative 5x to the first power, so it is linear. Makes a line if we graph it. Again, a monomial. Leading coefficient, 7. And this is, that's about all I can say about this, I think. The constant term is the leading coefficient, which is 7. So this would be a very boring polynomial. It's just 7 all the time. A trinomial here. 1, 2, 3 terms. Leading coefficient, -6. The degree, 3. This one has a quadratic term right here of -2x squared and a linear term of 7x, but it does not have a constant term. So the quadratic term is -2x squared. The linear term, 7x, and no constant. By the way, up here, the degree of this polynomial is 1, because there's really a 1 there. And the degree of this polynomial is 0. And the reason why is because really what we have going on is x to the 0 power. And anything to the 0 power is just 1. So if someone wanted to, they could write this as 7x to the 0 power, which would equal 7 times 1, which would be 7. All right, last example. The leading coefficient of this is not 3, because this is not written in standard form yet. So I'll rearrange the terms, 6x to the 4th first, so that the highest degree is first, plus 3x squared minus 1. Now, the leading coefficient is 6. The degree is 4. The constant, -1. The quadratic term, 3x squared. So if you've understood all of this, you should be able to work this problem where it says make your own example of a cubic binomial where the coefficient of the linear term is 7. So please think about that for a minute. Okay, so we're talking about a cubic binomial. Coefficient of the linear term is 7. Now, binomial is probably where I'll start. That means it has to have 2 terms. It has to be cubic for the highest degree, so that means this must be x to the 3rd. And the coefficient, the first number of the linear term, so this is linear, it must just be an x, and it has to have a coefficient of 7. Now, I could put whatever number I want here. Maybe I'll put 15. Could put anything. But 15x cubed plus 7x would be an example of a cubic binomial with a linear term having a coefficient of 7. Next class, you'll have an open note quiz. It is over this material.